Hey there, science fans. Today let's talk about those tiny but mighty components called capacitors. They're like the unsung heroes of the electronics world. You find them everywhere in our gadgets, from smartphones and laptops to TVs and even spacecraft. Capacitors are essential because they store electrical energy. Imagine them as tiny, rechargeable batteries that can charge and discharge super quickly. This ability makes them perfect for various tasks, like smoothing out electrical signals or filtering out unwanted frequencies. Without capacitors, our electronics would be noisy and unreliable. They'd be like a choir where everyone sings in a different key. Capacitors help to keep everything in sync and running smoothly. They're the conductors of the electronics orchestra, ensuring every instrument plays its part perfectly. So, next time you marvel at the wonders of modern electronics, remember the humble capacitor working silently behind the scenes to make it all possible. Now let's delve deeper into the fascinating world of these little charge storers and see how they work their magic. So, what exactly goes into making a capacitor? It's surprisingly simple. Imagine two conductive plates, like thin sheets of metal, separated by a non-conductive material. That's it. That's your basic capacitor. The conductive plates are like the bread of a sandwich, and the non-conductive material is the filling. This filling is crucial and has a special name: the dielectric. Don't worry, we'll talk more about it in a bit. The type of conductive material used for the plates and the dielectric material's properties determine the capacitor's capacity to store charge. Think of it like this. A larger plate area means more space to store electrons, like having a bigger bucket to collect rainwater. The distance between the plates also matters. The closer they are, the stronger the attraction between the charges and the more energy the capacitor can store. It's like holding two magnets close together. The closer they are, the stronger the pull. Now, let's talk about that special filling, the dielectric. This non-conductive material plays a crucial role in how a capacitor stores energy. Remember how opposite charges attract? Well, the dielectric helps to strengthen this attraction. When a voltage is applied across the capacitor, electrons gather on one plate, creating a negative charge. This negative charge influences the other plate, repelling electrons and creating a positive charge. The dielectric material enhances this effect by aligning its own molecules with the electric field. Think of it like this. Imagine the dielectric material as a bunch of tiny compasses. When you apply a voltage, it's like bringing a magnet nearby. All the compasses align themselves with the magnetic field. Similarly, the dielectric's molecules align with the electric field, strengthening the capacitor's ability to store charge. Different dielectric materials have different strengths, which affect the capacitor's overall capacitance. Choosing the right dielectric is crucial for designing capacitors for specific applications, just like selecting the right type of wood is essential for building a sturdy house. How do capacitors store energy? It's all about electrons. Connect a capacitor to a battery and electrons flow to one plate. The dielectric stops them, creating a negative charge. This repels electrons on the other plate, making it positive. Voltage builds up until the flow stops. The capacitor is now charged, ready to discharge energy.